I will talk about my haptics research. But before that, as I promised, I will mention about my retirement plan. Actually, I graduated Georgia Tech in 1991. My thesis was how to control the flexible long-reach manipulation. So it's a kind of teleoperations. And then I was recruited by Oak Ridge National Archive. At that time, Oak Ridge needs to make long-reach manipulator to treat the nuclear waste. So I was very lucky. But when I returned to Georgia Tech in 1995, what should I do? What kind of research area should I make? I have considered from telerobotics. So I decided to pursue haptics area because I was very interested in making some kinds of tactile and haptic feedback for teleoperation of the robots. And then until now, I have been in KAIST 23 years, and then alumni is 76, and the current member is 28. So I have a few years left. I have to make them finish within several years. Actually, my research area is in 3 areas: human-robot interactions, and then haptics, and medical robotics. And then haptics is a basis. I have extended haptics kind of interactions to human robots. And then I also applied some kind of teleoperation and haptics research to medical robots. Medical robot, especially for surgical robot, is a pure teleoperation system. So it was good to be to extend our research. In human-robot interactions, one of my former students, I am one of the co-founders, so we made some service robot companies. So that is what kind of representative Korean robotics company now. And I also established another company with former graduates, and then they is developing some kind of solar panel cleaning robots. So we'll see how it goes. Nowadays, they are very much interested in medical robots, so we are transferring some technology to them too. And then in medical area, we have developed many some kind of applications in surgery or a diagnosis. However, all of them are just went up to animal tests. None became any real things. So it was a little bit big burden to me. I have counted how many research money I have got from the government or from the company. It was quite big money. But what did I do? I just made students was a PhD degrees, zero, or published many papers. So I really thought, who is my boss in my life? Oh, who is your boss?
One on the right.
I asked this question to several people, and many people told my wife. And then now, young professors may think editors, journal editors, chief editor, who is it? They are deciding whether they will be promoted or not. Exactly. And then there are some company people think supervisor. They decide their salaries. And then nowadays, when we establish companies, investors, as real boss, I have to make them invest bring money to our companies within an hour. It was not so easy. Then some students may still take preferences, of course. But I thought my life must be myself. So I thought, can we do what we really want to do? So actually, and 60 years, some kind of celebration, self-free works. I went to South America for 3 weeks. So I had a very good time in Andes Mountains, Machu Picchu, and Galapagos. And then this is Uyuni sort flat. And then at the time I was thinking, how shall I close my research? Now I have a few years left to retire. So after return from that trip, I asked my students, at that time 27 students, I want to do something with a medical robot research. So who wants to join us? Join me, actually. So 80 students wanted to join us. So we established a sub-company called Easy Endo Surgery. And then we were developing plastic surgery robot system and then endoscopic surgery robot system, microsurgery robot systems. And then we decided to go this area as a first product. So this is one of the our research platform. This is master, very simple, very intuitive, and then this is actually this is camera over tube. It has a 16 joint, very flexible, but it's a strong. And then there is a robotic surgical instruments. This is very flexible one, and then size is a 3.4 millimeter diameter, and then it can lift about 300 grams to 200 grams. And then this is the strongest flexible instrument in the world up to now, at this size. So based on this technology, we established a start companies. It has a 300 gram weight, can really lift. So our idea is doing surgery with a very small space, with a very small motion and then precise motion. And then when we need big force, then we are utilizing the outer tube. So that is a story about human robot interactions and medicals. How about haptics? We have graduate. We have a lot of graduate in the haptics area. They become many famous professors and then companies, key persons, and research institutes. So our research in haptics was at the beginning. The first part was that we were concentrating making some kind of haptic device, especially some kind of kinesthetic feedback. Srinivasan didn't agree with kinesthetic, but I use this term as some kind of force display, force feedback in our muscles. So we developed many 6 zero freedom hand masters and then hybrid haptic masters, grasping mouse. Then, when I worked in Oak Ridge National Lab, my real question is, can we substitute some kinesthetic display with a tactile display? Kinesthetic display equipment is very large and heavy, but if we can utilize tactile display for some kind of teleoperation system could be very compact. So we were focusing on some kind of how to display tactile feelings. So we created some piezoelectric mouse and ultrasonic display, actually it's ultrasonic actuator display, and we made a very small actuator with the voice coils, and we also made a haptic buttons with using magnetobiological fluids, and we also made some kinds of impacts, a resonant actuator using voice coils, and we also made some surface haptic display with the electrostatic and the mechanical vibrations. And then currently we are concentrating on making brain haptic displays. So since I'm becoming old, I'm having the different some kind of scale time. So just sign up 5 minutes before. Okay. So, but the haptic actuators, we were looking for some real, what is the actually key applications in haptics. So we were focusing on some mobile applications. As you see, we had a smartphone or a feature phones, but actually inside the actuator, it's still not much improved. So we have made many different small actuators, and I will talk about a little more in detail. At the 1990s, the feature phone has this kind of essentially rotating mass motors. It's very powerful, small, but it consumes very low power. However, stop response is not so quick, sharp. So stopping time is about 200 milliseconds. So we couldn't have any crispy feelings. So mobile phones has utilized a linear resonant actuator. It vibrates, and that is much crisper than these motors. Response was 25 milliseconds. However, still 25 milliseconds, people doesn't feel the crispiness. But this is still used more than 20 years. And then why the linear resonant actuator is not popular? Because they are using the resonant frequencies, so it consumes less power. It is resonance actuator means like a spring-mass system. So it's just giving slight actuation, and then it vibrates with the resonant frequency. But we changed some kind of idea in different way. Like this. This one is always a stable position in the center. But if we make actuator in this way, if at the neutral position is unstable, and then it goes, then the velocity becomes faster, and the hit it like this. So it's a kind of impact actuator. Then that feeling is very crispy, and then we can also change the frequency arbitrarily. This one is a very good impact at the one frequency, but we can do arbitrary frequencies. However, in this case, it consumes more power than this one. So we slightly modify. At the center, it is a resonance. It has a resonance, but at the side, it has an impact like this. So it still have two advantages. So frequency response is very wide, and the feeling is very crispy. So we made this one, linear impact resonant actuator, like this. So we can vibrate from 0 frequency to about 100 hertz, 200 hertz arbitrarily. So I showed this one to Samsung Who's is from the Samsung? No.
No one.
Then yeah, and then they were very excited, so they gave us some money, and then we were very successful to make this one. So I had a chance to be a billionaire 10 years ago. But there was some business chase, so it was not commercialized. And then in technical wise, we didn't have enough fund or money to develop more. It has a certain noise. When it impact, we have to reduce the noise, but we didn't have a chance to do that. And then the spring is very fragile, so we need some kinds of more engineering technology, but it hasn't been supported to us. So it hasn't been commercialized, and then it couldn't pass the some kinds of robustness test from Samsung. So it has been stopped. Actually, we had a similar system developed, supported by LG companies. So they were also very excited. But after finishing that product, the high decision level top management people asked, Samsung is doing this one or not? So not yet. Then we do not do either. So it has been continued. So it was a little bit disappointing. So we changed our focus, some interest focus to surface haptics. Okay, let's forget about this small actuators. As was Chatai, sorry, Chatai or Chatai, or is it? Chatai explained some kinds of electro vibration. We could display some kinds of textures. And then I had a little bit different idea. With the electro vibration, it display some texture feelings when we only move. If we just press, we don't feel anything. So we try to combine mechanical vertical vibration and then horizontal electro vibration. So I won't go detail in technology. There are some other young people, especially Dr. Pyo. He's a key person of this area. So we made one more layer. This one is electro vibration layer. This one is a mechanical vibration layer. So when we press and stage it, we can still feel the vibration. So with that vibration, we could express something. And then if we combine those two vibrations, when we are sliding, it could create some kinds of different feelings. It has some masking effects. So we researched about here more deeply. And why we did flexible? Okay, so we have got some basic technology in surface haptics, and we were very curious of what is the applications. So I told my students, let's go to the car. Car display will be very large, and then car cannot use just flat surface. It has to be flexible. Then when we use a big screen in the car, touching needs some kinds of tactile feedbacks. So we were focusing on flexible display. So flexible display is coming out. Technology is there. So if we just add one more tactile display on the top of the flexible display. So Kyo has worked on here, and then Dr. Pyo has worked on here. But we found out the tactile display should be very thin and should be transparent. And then at the first stage, we could make some kinds of vibrations. How about if we press a little bit strongly, vibration cannot be generated. Yeah, you can easily make a very small thin layer. If you press it, then the upper layer, lower layer just pressed, doesn't produce any vibration. So we are focusing how we can create vibration even though it has a hard pressing force. So in some sense, we had made a lot of different design of these layer structures. So finally, we ended up this kind of design, and then make this kind of flexible display. Okay. But there are still issues about transparency. Yeah, if we make that this way, then as you see, even though this is PDMS material, the transparency is not enough. It's not so good yet. So we need to improve a little about this kind of display issues. Anyway, flexible actuator has been developed, and then it can resist a strong pressing force. So actually, at that time, about 4 years ago, this guy came to me, and then even though he didn't study in our laboratory, he wants to be regarded as one of my graduates because he wants to have our all-out technology. So I asked him, what do you want to do? And then he wants to make a braille display for visually impaired persons. So I thought his motivation is very good. So I decided to give all our technology to them. He made a dot company like this, and he was very successful in making watches. But I was a little bit doubting about their business. It's good, for advertisements, but actual product market is not so good. So let's go to the haptic pen. So we, based on this all small actuator technology, we were working on making small actuator that can be linked together to make a big screens. So this is kind of iPad size, and the depth is 5 millimeter diameter with a thickness, and it should be light, less than 200 grams. Yeah, that is less than 2 kilograms. Okay. That was our primary design requirements. So these days we made some kinds of braille display module like this. So at the beginning, we started from just one pin module, and we added 2x4 modules, and currently it's a 4x4 modules. And then important thing is low power consumptions. So power has to be used only for changing making the motions. If the braille display is coming up and stays there without any power consumption, that was the most critical things. So we made many ideas how to push and pull and stays there without any power consumptions. So several ideas has been generated. Like this is the first idea. Sometimes it's rotating. Still rotating, and then goes push up more like the CAM system. And there are several other systems being tested right now. Up to now, this is has a good performance, but still, we are developing more different ideas. can you see 10 millimeter, 10 millimeter, 5 millimeters, and then 4 by 4 size is less than the coin. Currently, in the market, there are some kinds of braid actuator using piezoelectric plates like this. It's heavy and it costs $30, and it requires piezoelectric beam because of very high voltage. So we need some kinds of voltage converters. And in here, we don't need the big power and small enough, very cheap. So our all long history technologies of haptic actuators is going to that and to braid actuators. So I'm asking you again, who's the boss? And then these days I was not much comfortable to present in front of investors. But I couldn't get rid of all these my bosses. So I decided to regard bosses, many bosses in my life, as my friend and supporters. Then I can be much more happier. At my medical company, we are developing many different systems. I think that the small startup companies, there is no company who are developing 7 product medical surgical robot systems. If it is really successful, yeah, then I may have to change my tires of my car again. I'm really looking forward to collaboration as a researcher and as a business person. I want to utilize haptics technology in medicals. So if you have any good idea, please let me know. I can buy your technology. We can be rich together. Thank you very much.